Hello, this is our section. This is where our notes start. Here are your notes. We are talking more about the slope of a line. We talked about slope in the last section. We looked at proportions and slope, and we used several terms for slope. Unit rate, constant proportionality, constant rate of change. All of these things we use to describe our slope, and now we're going to look at, in a more technical term, I'm kind of looking at the graph of a line. So the term slope is used to describe the steepness of a line. So the larger the slope, the steeper the line. And you guys know, you see the signs all around town, like it'll have the percentage of the steepness, and the larger that percentage is, the steeper that slope is. Driving here is a lot scarier than driving back in Illinois was because of the steepness of some of the slopes here. But again, we said it's the rate of change between any 2 points on a line. So the vertical change, or the y change, is called the rise, while the horizontal change, or the change in x, is called the run. So slope, another way to think of slope now, is the ratio of the rise to the run. And again, in linear relationships, the slope is always constant. So slope you can think of as rise over run, which is the vertical change, how far up or down the points, how far up or down you go between points, over how far left or right you go between points. Slope can be positive or negative. So a line that goes upward from left to right is positive, and a line that goes downward from left to right is negative. So lines that have a positive slope will always go in this direction. From left to right, they are going up. Lines that have a negative slope will always look like this. From left to right, they are going down. So you should know that if you see a line going in this direction, the slope is positive, or if you see a line going in this direction, that the slope is negative. Now this is on page 192, so you can flip to page 192, and there are some boxes to fill in on page 192 at the top. So for this graph, you can find the ratio of the rise to the run between any 2 points. So if I know these 2 points on the graph, then to get from this point to this point, I have to go up 3 and to the right 4. So we go positive 3 and positive 4. So our slope, and you could fill this in, there's boxes to fill this in, is 3 over 4. So when reading the rise and run from a graph, up is positive, down would be negative, right is positive, and left would be negative. So it is important to understand which direction, and you should know that if you see a graph going this way, that you know that your slope should end up being a positive number. So let's look at an example of this. If we want to find the slope from a graph, and I know these 2 points on the line. This is the graph that shows the cost of muffins at a bake sale. For 1 muffin, it was $2, 2 muffins, $4, 3 muffins, $6, so on and so forth. So you guys should actually know the slope already based on what we talked about in the first section, but we can also find it this way. If we're not looking when x equals 1, which is one of the ways we learned, when x is 1, y is 2, so that would be our slope if it's a proportional relationship, which this one is. But we can also look at any 2 points, and so let's find the rise on this graph. We see that it goes up 2 and then over 1. So the rise over run is 2 over 1, so the slope of our line is 2. Now without finding the slope, we can tell that this is going to be positive because it's going up and to the right. So now on the top of page 193, you guys see if you can figure out the slope of that line at the top of page 193. So pause and find the slope for that one. We'll look at one other example really quickly here. If I'm looking at these 2 points and I want to find the slope, then from this point, I go up 1, 2, 3. So my rise is 3, and then I move over 1. So 3 over 1 would be my slope, or just 3. You could simplify to just 3 for this graph here. This one shows the amount of water leaking in a bucket over time. This is not a proportional relationship because remember, if it's proportional, it starts and it goes through the origin. And we were really looking at ones that went up to the right. So direct variation, all the ones we had were sloped positively. So this one now, if we want to find the slope of this line, first of all, is it positive or negative? You should know without doing any work that the slope of this line is going to be negative because it's going downward. And again, we just take 2 points on the graph, or on the line. So from this point, if I want to get from this point to this point, my rise is actually negative. So we're actually going down 4 and over to the right 6. So a negative 4 and a positive 6 to get from this point to this point on the graph. Does that make sense? It's like the vertical change and then the horizontal distance that you would travel. So negative 4 over 6, and we should simplify this to negative 2/3. Yeah, for some reason. Anyway, negative 2/3 is what should go there. So you guys can fill that in the box. On page 193 is where we are. So the slope of the line is negative 2/3 when you simplify it. Let's look at another one. So here, to get from this point to this point, we would go down 2, so negative 2, and we would go 1, 2, 3, 4, 5, 6, it looks like. 1, 2, 3, 4, 5, 6, yes. So negative 1/3 would be our slope. And again, we should know right away that the answer is going to be negative just based on the direction the line is going. Alright, so at the top of page 194 now, you guys see if you can find the slope of that line for that check problem. And then, now that you're back, go to page 194, and you should be able to find the slope not only from the graph, but also from a table. So again, we can find the slope by finding the ratio of the vertical change to the horizontal change, x. So here's our x, here's our y. We can find the difference between x and y. So the difference in the y's, and then the difference in the x, and then find our slope just using the change in y over the change in x. So this table shows a relationship between the balance in a bank account and the number of transactions. Again, you can fill in some of these things on the bottom of page 194. But if you look, after 3 transactions, there was $170. After 6 transactions, $140, so on and so forth. Well, what's the difference in each transaction? The y is going down 30 each time. So our change in y is negative 30. And our x, our number of transactions, is going up by 3 each time. So our change in x is 3. So fill in those boxes on page 194. So the overall slope is the change in y over the change in x, which simplifies to negative 10 over 1, or just negative 10. We really don't need to write over 1. So let's look at an example of that. Here is a table, and the points given in this table lie on a line. So these are all points that fall on a line. So how can we find the slope from the table? Well, again, we really only need to look at 2 of the points in the table and find the difference in the y values and the difference in the x values. So let's use these 2 points. We'll use negative 6, negative 2, and negative 2, negative 1. Again, you could kind of look at the table on page 195 at the top and follow along. So if we find the difference in the 2 points, for the y's, first of all, I'm going to take that first point, that negative 1, and subtract negative 2, and then negative 2 minus negative 6. So we're finding the difference in the y values over the difference in the x values, and we get 1/4 for the slope. So the slope of the line is, you guys can fill that in, 1/4. Let's look at another example of that. Okay, so with this one, again, we're going to, and some are easier than others, especially if they're all positive. It's not quite as much work, and we're going to look at other examples using the formula that will make this a little easier. But what's happening with y? If you notice, each time it's going down 3, right? It's getting smaller by 3. And with x, each time it's going up 2. So my slope would be negative 3 over 2. So you guys pause and try the check problem on the bottom of page 195. And after you've done that, you can stop the video. But you can watch this first. Here's a little video for you to watch.
You have to stop asking people for likes and follows. Like and follow if you agree.
So like and follow if you agree, and you could pause the video here and then continue tomorrow night for homework. But I'm going to keep going. So you can pause now and starting the next video. So you don't have to do this till Tuesday night. And this starts on page 196. Okay, so today we are going to find the slope using the slope formula. And the formula is based on knowing any 2 points on the line. So you can, if you know any 2 points on the line, then we can use the slope formula. It doesn't matter which points, you know, any 2 points, we'll call one of them x1, y1, x2, y2. It really doesn't matter which one you make which. But the thing that does matter is that the coordinates of the points must be used in the same order. So here's, first of all, in words, the slope of a line. Passing through these points is the ratio of the difference in y over the difference in x. And here's the actual formula. So we have m, which stands for slope, equals y2 minus y1 over x2 minus x1. And you guys might want to like circle this because you're going to be using it a lot in the rest of this section. But for y2, y1, it doesn't matter which one you pick, but the key thing is whatever one you pick for the top first, you have to use that corresponding x coordinate for the bottom. And so these pairs go together. It doesn't matter which one you choose first or second, but make sure that the pairs are in the same order here. And I see students mess this up all the time. They'll start one point with the y and a different point for the x. So here's what we mean. Here, if we have, this one could be x1, y1, or this one could be x1, y1. It really doesn't matter. But this is the formula, so you'll need to be able to use that quite often. And you can just watch this really quick to find how the slope can be found using this formula.
If you know 2 points on a line, you can use the slope formula to find the slope of the line. The slope of a line m is equal to the rise over the run, or the change in y over the change in x.
By the way, you can fill in the boxes on page 196 while you watch this.
To find the change in y, subtract the y coordinates. To find the change in x, subtract the x coordinates. So, the slope formula is the ratio of the difference in the y coordinates to the corresponding difference in the x coordinates. Substitute the x and y values from both points in the slope formula. Use coordinates 1, 3 for x sub 1 and y sub 1, and use coordinates 5, 6 for x sub 2 and y sub 2. Now simplify. The slope of the line passing through the 2 points is 3/4.
So you could have done 3, 1, 1, 3 first, and then 5, 6. And if we had done that, 3 minus 6 over 1 minus 5 would have given you negative 3 over negative 4, which you guys should know would also equal positive 3/4. So like I said, it doesn't matter which one you pick to be x1, y1, x2, y2. But notice that the 5 and the 6 go together in the same position, and the 1 and the 3 go together. So it could be the 3 and the 1 and the 6, 5 here. That doesn't matter. You'll get the same answer in the end, but make sure you keep like a point together in the same spot. And also, So many people do this. Y is on top and X is on bottom. So it's the difference in the Y over the difference in X. So make sure you put the Y's on top and the X's on bottom. So let's look at an example of using the slope formula to find the slope, and this is on page 197, so you can follow through and fill in the boxes on page 197. So we want to find the slope of the line that goes through these 2 points, -4, 3, and 1, 2. So first of all, right away, you should know that your answer should be what? Since the line is going this way, we should know that our final answer should be negative. So if you end up with a positive answer, you know you did something wrong. So since this line is going down, my slope should be a negative number. So here are our points, and here's the formula. We're going to pick one of these to be x1, y1, and we'll pick one of these to be x2, y2. So in place of y2, we put 3. In place of y1, we put 2. So we're subtracting the y's, and then we're subtracting the x's. And since I picked this y first on top, this x has to go first on bottom. So notice that -4, 3 are in the same position, and 1, 2 are in the same position. Again, we could switch the order. It wouldn't matter. Our answer would be the same. So it really doesn't matter which one you pick to be what. But then when we simplify this, we get 1 over -5, or just -1/5 for our slope. So the slope of the line is right here, -1/5. It's kind of redundant, this book. Now, if we chose the other one to be, oh, here we go. Hold on. It doesn't let me go. Okay, so in the book on page 197, they do this the other way around. So they switch it and make this x1, y1, and this x2, y2. So fill this in and let's see what happens here. So if we do that, if I make this that, and this that, then y2 minus y1, basically these just flip over x2 minus x1 is -1 over +5. So either way, like I said, we get the same thing. So it doesn't matter which order we do this, we get the exact same slope. So you guys try the one on the bottom of page 197 and see if you can get the slope for that one. So now on page 198, what if the line is not slanted diagonally? What if it is horizontal or vertical? So now we're going to look at horizontal and vertical lines. And if the line is horizontal, then it has a slope of 0. If it's vertical, then it is undefined. And the way I try to help people remember horizontal lines, you can ski, what's it called, cross-country skiing, right? So you can ski on a flat surface. You would just have to, it would be cross-country skiing. So this has a slope, but the slope is 0. Whereas this one, if you tried to ski this way, what would happen? Flat. So you would probably not end very well. So vertical lines have no slope. You don't want to ski down a vertical line. It will not end well for you. So the slope here is 0. The slope here is undefined. So every horizontal line, the slope is 0. Every vertical line, the slope is undefined. So if you want to go to page 199, we want to find the slope of this line, and it's horizontal. Remember, horizontal like the horizon, vertical like vertical blinds, okay? So keep that straight. But with horizontal lines, you can either look at the line and say that the slope is 0, but you can also use the formula. If I use the formula for this, and I have y2 minus y1 over x2 minus x1, so 4 minus 4 over this minus this, right here. Then when we do this, you end up with 0 over -5, which 0 divided by anything is just 0. So the slope of the line is just 0. Now, in the check problem, I want to do this with you really quick. in this check problem, it gives us the points -4, 5, and 2, 5. Actually, I'm going to let you do the check. I'm going to do this one with you guys. Okay, if I want to find the slope of the line that passes through these 2 points, one thing I always recommend doing is draw a picture. So -1, -1, 7, and 5, 7. Draw a picture of those 2 points. Because if I draw a picture and connect them, then I can see right away that this is a horizontal line. So I don't have to do any work to find my slope. Why does it do that? I can see right away that my slope is going to be 0. Okay, but if you don't draw a picture, you have to use the slope formula, y minus y, y minus y, x minus x, 5 minus -1, and you end up with 0/6, which is also 0. But if you draw a picture right away, you can see that it's a horizontal line, so you don't have to use the formula. If you don't draw a picture, then you have to use the formula. But even if you use the formula, I always recommend drawing it. Draw it. The more you can see, the less you're going to have to do in your head, the better off you're going to be. So now you guys pause and try the one on the bottom of page 199. And then last thing for today is lines that have an undefined slope. So if the line is vertical, the slope is undefined. But let's just look at what would happen if we tried to use the formula here. So if I was going to use the formula for this line, I know 2 points on the line. We're using the points 1, 3, and 1, 0. So plug those into the formula, x1, y1, x2, y2, 0 minus 3 over 1 minus 1. And look what happens here. You end up with -3/0. Can you divide by 0? No. So the slope is undefined. Okay. Now the way I like to tell people is that 0 on the top is okay, but 0 on bottom is no slope. We cannot divide by 0. 0 on top is okay. This equals 0, right? But 0 on bottom is not possible. It is undefined. So when the 0 is on bottom, when the change in x is 0, it's a vertical line. When the change in y is 0, it's a horizontal line. So 0 on top is okay. 0 on bottom is a no-no. But again, if you draw a picture, you can see without using the formula. So this one, if I have 2, 4, and 2, -1, here's 2, 4. Ooh, oh my goodness. 2, 4, what in the world? Okay, and 2, -1. Then I can see those make a vertical line. So without doing any work, I can find the slope. But if I end up using the formula, we end up with 0 on bottom. 2 minus 2 on bottom equals 0 on bottom, which our slope is then undefined. So you guys pause and try the check problem on the bottom of page 200. And that's it. That's all we've got for this section. Okay, until next time.